Hello and welcome to Introduction to Networks Module 2, which is all about basic switch and end device configuration. When a network device comes out of the box, it'll be configured with a day one configuration, just a basic default configuration. But of course, it will need to be customized and configured for the network it's going to be operating on, including secured. Let's start by learning the basics of how to navigate and use the internetwork operating system that comes on the device. This module will get you started on accessing and navigating the Cisco IOS or Internetwork Operating System, how the commands are structured, how to use the command line interface, how to save a configuration, learn how devices communicate using IP addresses, and how to configure an IP address on device as well as to verify the connectivity between two end devices. Part of the operating system that interacts directly with the hardware and underlying electronics is called the kernel, and the kernel is going to manage hardware resources and interact with the software use of those resources, whereas the portion of the operating system that the user is going to interface with is called the shell. The user can interact with the shell using either a GUI or a CLI. So what are advantages and disadvantages of using a GUI interface or CLI to interact with the operating system? Well, a GUI is more aesthetic, it's more user-friendly, you can point and click your way through if you don't have a lot of knowledge of the underlying command structure, but you still want to be able to get work done. And of course, we use these on a daily basis. Windows, Mac OS, Linux, KDE, which stands for K Desktop Environment. Another Linux GUI is GNOME. Then you've got Apple iOS and Android, of course. Disadvantages. Well, what if it fails or crashes or doesn't have enough options? What you want to do if you're running a network is you want to be able to always have the command line interface as your means for managing a device and to have that underlying knowledge of the commands. Now that said, if you're configuring, say, a home router, which is operating using firmware, commonly that would be done by a web browser-based GUI. For the purposes of this course, we will be using the command line interface. The Cisco IOS, that term refers to the family of network operating systems on Cisco devices. Depending on the product line, there are within that family operating systems, if you hear the term iOS XE, iOS XR, and then there's another operating system within that family on the Nexus line of equipment, which is called NX-OS. But those terms all refer to the broader term iOS. How do you start off? How do you access the switch? One way is this console cable, which is this trademark light blue Cisco cable example seen here, which is a DB9 to RJ45. Another type you might use would be a RJ45 to mini USB, which you can buy from third parties. The console is the physical management port. There's actually an RJ45 port on the device marked console. That's dedicated out-of-band access. What does out-of-band mean? That means that you are accessing that Cisco device via a dedicated management channel that is built in and used for device maintenance purposes only, nothing else. It's not a network port. It's strictly to plug in that console cable and to configure the device. You can use this to perform, the initial configuration of the device, or if you're doing any really important configuration that you don't want to have messed up in case there's a network outage, you should use a console, an out-of-band connection. And to do that, you're going to use a terminal emulation software program. And we're going to talk about the terminal emulation program a little bit more in a minute. Another way to access this network device would be remotely over a network. You might just want to do a command or look at a status of a connection or something like that. You don't need the console to do that. If you have a network connection, you could use the telnet protocol to establish a connection over the network. From a security standpoint, the advantage of using Secure Shell or SSH instead is that that will be a secure connection. That will be an encrypted connection to use the most secure connection possible. The disadvantage of Telnet is that anything that's sent is going to be in plain text. So if there's a threat actor with a sniffer who can view that traffic, they could actually steal the username and password of the Telnet connection because it is sent in clear text. But with Secure Shell, that would be encrypted. Keep in mind that these types of access methods are called in-band. So these are both in-band methods, and the opposite of which is the out-of-band method, which is the console that is a dedicated management channel. Another access method that's not shown here is an AUX port, which is also an out-of-band port like the console port. So console or AUX are both out-of-band access methods. The AUX port was commonly used back when there was a lot of dial-up modems to access network devices. So you could access the modem via telephone, and then that would connect to the aux port on the device so that you could dial in to manage it via out-of-band access. So that is an option, it's just not shown here. So a terminal emulation program is simply a program that would allow you to interface with a network device. For example, here they're using SSH in PuTTY is the name of this one, and SSH uses TCP port 22, and then the reference that it puts here is this unique IP address of the device that is being connected to via SSH, which in this case, then, once you click open in this configuration window, that's the terminal emulation program is going to open up a terminal session once it connects. The example they've logged in, supplied the password, and now is given the configuration prompt for the device, which looks like is named R1. And some of the most commonly used terminal emulation programs are PuTTY, Terraterm, and Secure CRT. Once you've got your terminal emulator and you've opened up your session using either SSH or an out-of-band connection, next is navigate the operating system. One of the security features of Cisco iOS is that there are two levels of privileges or access. And if you're familiar with Linux, regular user access, where you have the $ prompt and you're limited to what access or commands that you have, well, just think of the equivalent of that in Cisco as being user exec mode, short for executive. So with exec mode, you have this greater than prompt, and you're limited to basic monitoring commands. So when you see the greater than prompt, you know that you're in the exec mode and that your capabilities are going to be limited. The analogy to, say, super user in Linux or Unix in the Cisco speak would be called privileged exec, privileged executive mode. You see the hash symbol prompt, similar to that other environment, and when you see this prompt, you know that you're in privileged exec mode and that you'll have access to all the commands and features. To be able to make changes, go into what's called configuration mode. And under configuration mode are going to be sub-configuration modes. So the first thing you have to do is get into privileged exec. The global configuration mode, which is your starting point to access configuration options on the device, will give you the prompt that looks like that. So if you see that prompt, you know that you're in global configuration mode. If you need to get into a specific sub-configuration area, in this example, config-line is the prompt because they've gone from global configuration mode into line configuration mode using the line command. This is where you would be if you were configuring your out-of-band access, such as console or AUX for auxiliary, or if you're configuring your SSH or Telnet which is going to be your virtual terminals, your VTY lines. That's what line configuration mode. So out of band and in band access is going to be under line configuration mode. If you're configuring an interface, like say you're connecting switch to an upstream router, then you would be using interface configuration mode. And that's going to be the specific area for all the interfaces on that device. And then that is what your prompt would look like, config-IF. So while we're talking about the differences between these modes, let's also talk about how to navigate them. When you first connect to the switch and see that greater than symbol, remember that's the exec level, that's the limited capabilities. To switch to the privileged, think of the super user equivalent, enable is the command that will elevate you to privileged exec. So now that the enable command has resulted in the elevated privileges, so indicated by the hash symbol, let's talk about how to move in and out of global configuration mode. The configuration mode is where most of your configuration is going to take place. To go into global configuration mode, first you have to be in privileged exec mode by typing enable, or EN for short. It's not shown in this window here, but to get from here to here, the command is configure terminal. So configure terminal is the command to get from privileged exec to global configuration mode. That will give you the config prompt, and then to return to privileged exec mode, you would use the exit command to leave configuration mode. Line configuration mode is where you're going to set up your in-band and out-of-band access, telnet, SSH, console, auxiliary, etc. Not interfaces. Don't confuse lines with interfaces. The command would be line, but not by itself. It would be followed by the name of the line that you're configuring. In this case, it's the console, line console 0 or line con 0, and that's going to put you in a sub-configuration mode, which is indicated by config-line, which is nice because the prompt's going to help show you and help you remember kind of where you are within that hierarchy. So you would type in the commands that you're putting and applying only just to the console in this case, and then exit when you're done will then take you up one level to global configuration mode. Configuring a network interface, such as to the upstream router, you would go into interface configuration mode, which is similar, except from global configuration you would type interface, or INT for short, instead of line, followed by the name of the hardware interface that you're applying your configuration to. Once you've done your configuration and you're in the sub-configuration mode, you would move up one level by using the exit command. If you want to go all the way out back to privileged exec, you would type end. You don't have to type exit twice. End will take you all the way back out to privileged exec mode, and the equivalent of the end command is Control Z. If you want to move from one sub-configuration mode to another, you can. You don't have to exit out of line mode back to config mode. Now let's take a look at the command structure. This is the prompt, which by default is the name of the device, and by default out of the box, the switch is going to have the hostname switch. And then you've got the greater than sign as part of the prompt, which tells you that you are in exec mode, you're in limited mode. But from that mode, you can do some show commands. So the command is show or ping. So first comes the command, and then a space. And then you just want to know the difference between a keyword and an argument. Well, a keyword is a predefined parameter in the operating system. IP protocols, which is a keyword, IP and protocols is predefined, and so that is called a keyword. An argument is something that's not predefined. You can put in what you want. So ping is the command, then there's a space, and then this is an argument because the user is defining this. That's the difference between an argument and a keyword. When you're given a command syntax element, what they mean is if there's boldface font, that means you enter the command literally as shown. If it's in italics, that means it's an argument, meaning you supply the values. It's not a predefined value. If you see square brackets, that means that element, keyword, or argument is optional. Square brackets means optional. Curly braces means required, keyword or argument. And if you see something like braces and vertical lines within square brackets, this is an optional element. But within that, if you do use that optional element, then these are the required choice within that optional element. So to illustrate this, for example, ping is in bold as shown, and then IP address is in italics, meaning it's an argument that you as the user provide the value. Same as with traceroute, which is used to trace the path through a network. Again, that would be the literal command, and then in italics means you supply the IP address of the destination that you want to trace all the hops to. And if a command is more complex than one of these and has multiple arguments, literal command is switch port, port security, aging, and then within that, your curly braces tell you that you are required to specify static, time, or type, and within type, you have to specify absolute or inactivity. And within the operating system, there are a couple forms of help available to you. The context-sensitive type of help makes use of the question mark. For example, if you know the command, but you want to know what keywords or arguments are available, you would type the command, a space, and then a question mark, and it would give you some information. If you wanted to list all of the commands that start with the letter P, you would type the letter P, question mark. You could simply type a question mark by itself, and it would list all of the possible commands depending on which command mode that you're in. And then you've got something called command syntax check, which when you enter a command, if the command line interpreter cannot understand the command being entered, it will give you some kind of feedback. So in this case, on a switch, someone has typed in the command interface fast Ethernet 0/1. If you are in privileged exec mode, but not in configuration mode, because that's a configuration command. So if I go over here to packet tracer, as you can see, that is a valid interface, fast Ethernet 0/1. If you wanted to do a show command for fast Ethernet 0/1, then that's going to be a valid command. And again, you could do a question mark to see what various options are. But if you want to do the interface fast Ethernet 0/1, you have to go configuration mode. So you would type interface fast Ethernet 0/1, and then that is a valid command in config mode. And from interface configuration mode, you could do something like give that interface an IP address. Let's say 10.0.0.1, and it's going to say, oh, something's wrong here. There's invalid input detected here. You can't do an interface address on this interface because it's not a layer 3 interface. So there are various parameters here that you could use, which would be IP ARP or IP DHCP, but not specify an IP address. Commands can be abbreviated as long as they're unique. For example, to go into configuration mode, if you were to type CON, that wouldn't work because it's not just short for configure, it's also would be short for connect. And you can determine that by just typing CON question mark, and it will list all of the matches. So if you were to type in CONF, that's good. If you were to actually type a question mark at that point, you would find that there's only one command, subcommand of configure that begins with a T, which is terminal. So instead of typing out terminal, you can simply type T. It's always good to reduce typing and use shortcuts. And there are some shortcuts in the iOS, similar to Linux. For example, there is tab completion. If you want to move the cursor one character to the left, the equivalent of the left arrow would be Control B for back, or to move the cursor one character to the right, equivalent of right arrow would be Control F for forward. If you want to recall a command, you can either up arrow or Control P, kind of the equivalent of like when you do a man page in Linux, where it's paged through more. There is a similar feature in iOS where it'll paginate multi-screen outputs, and when you're in that mode, enter key will page ahead one line at a time. The space bar will page through a screen at a time, and any other key will exit out. If you need to exit out of an operation, you can use Control C or Control Z. And if you get stuck in a domain name lookup, which I will illustrate in a second, you are definitely going to always want to remember Control Shift 6, which is basically a breakout sequence when you've lost control of the command line. So going over to Packet Tracer, so there's a command called Show IP Interface Brief. That's a good basic command which will show you here on a switch. It's going to list all of the interfaces. So if I wanted to abbreviate that command further, I could say S question mark. In order for show to be unique, I have to type at least an S and an H. And if I hit the tab key at that point, it's going to complete that for me. There's the tab completion. So show, and then IP, if I type I question mark IP, I'm going to type that out, and then interface. There's only one subcommand that starts with I, so I can abbreviate interface just simply to the letter I, and then for brief, B question mark, again, that's the only subcommand that begins with a B. So the shortest possible way that I can abbreviate show IP interface brief in iOS is show space sh space IP space I space B, and there's the output. Now just to show you some of the hotkeys, so if I up arrow, recall the previous command, or the equivalent would be Control P. Unfortunately, there's not a history feature like there is in Linux. Similar to Linux, you can do a Control A to go to the beginning of the line. The hotkey to go to the end of the command line is Control E. Control B if you want to go back one character. Control F to go forward one character. Another useful one is Control W for wipe. That will wipe one word at a time up to the next space. If I want to delete that entire line, it's simply Control U. The other thing that can often happen with anybody working on a router is if, let's say I accidentally forget which operating system I'm in and I type in CLS to clear screen, the switch thinks trying to do a domain lookup of something that matches CLS, and there's a command you can actually configure to keep this from happening. Again, that's going to sit there like that. Control C is not working. Control Z is not working either. What you have to do to get out of this is Control Shift 6, and that'll take you right out. Now we get into the fun part, which is the actual configuration. So first of all, when the switch or the router comes out of the box, as we've said, its factory default name is going to be either switch or router. You want to be giving it a unique host name. It's best to give them descriptive names. The guideline that Cisco gives for naming devices is just start with a letter, have no spaces in the host name, and end with a letter or digit. Use only letters, digits, and dashes. Less than 64 characters. First, you have to be a privileged exec. Then you want to go into global configuration mode. Configure terminal. You can shorten it to CONF space T. Once you're in global configuration mode, as evidenced by the config prompt, the command is hostname. The hostname command will in turn change the prompt. We can tell they're giving it a descriptive name, SW for switch, dash instead of a space, and they're annotating the location. So the name describes this as a switch and it's located on the first floor. The name is less than 64 characters in length. It begins with a letter, there are no spaces, and it ends with a letter or digit. As soon as you use that command to change the host name, the prompt is immediately going to change as well to the new host name. To return back to the original default factory name, simply use the no space host name global configuration command. Now that there's a new host name, next we want to limit administrative access. You want to secure everything you can secure, including your privileged exec mode with those advanced commands. Even the user exec, even though that's basic command, you still want to secure that as well. You want to secure your remote access. All passwords should be encrypted. So how do you set a password? We'll approach those one by one. So the first thing is the initial entryway into the device. At the console level, first of all, privileged exec mode, then global configuration mode, config t, conf t, configure terminal. Now that we're in configuration mode, use the line command because we want to go into line configuration mode. We'll start with our out of band, our console. So line con 0 or line console 0 will put us in line mode for the console. The password command is pretty straightforward. We're setting the password on the console, and that password's going to be Cisco because this is a classroom. You have to use the command login. If you don't use the login command in a hand-in-hand with the password command, it's not going to be effective. And then end will exit back to the privileged exec mode. For example, over here in Packet Tracer, I've set the line con 0, the console, with the password of Cisco, but I did not put the login command in. So what happens is, here I've logged out of the console. If I hit return, it didn't apply it. I'm still able to access the console, and I can, do some basic commands because I'm just in that exec mode. But if I go ahead and go into privileged exec mode, then go into config mode, line con 0 to go into line mode, and I say login. So now if I exit out, now it's working. You have to make sure you get that login command in there as well. So now exec mode is secure. So next we want to secure our privileged exec mode access, our super user, if you will. First go into privileged exec mode, then configuration mode by typing conf t, and the command is enable secret. The argument is the user-defined password that's being assigned, which in this case for the course is going to be class. There are two different ways of setting the enable password. There's the enable password command and the enable secret command. Let me show you the difference between the two. So if we go to Packet Tracer, currently privileged exec isn't secured, so I can simply type in en and freely get to the privileged exec level. So if I go into configuration mode and I type in just simply enable password, and I set that to class, what I can do is from here, a little trick I can do is use the do command. Instead of exiting back out to privileged exec prompt, I can actually look at the show running configuration. Now this goes through pagination, so what we talked about before is if you press enter, it'll go through one line at a time, or I can press spacebar to page through one screen at a time. But at the very top of that, the configuration for the enable password. So what do you see about that? It's in clear text. So if somebody was looking over my shoulder right now, they would see that the enable password to get into privileged executive mode on the switch is CLASS. That's the difference between using the enable password or enable secret command. So if I go back and I say, I'm back in configuration, I didn't exit, I say enable secret CLASS. So it's saying the enable secret you have chosen is the same as your enable password. This is not recommended, but that's okay. It's nice to get that feedback, but we're going to actually go ahead and take care of that after I finish this demonstration. So if I go back and do a do show run, do you see the difference there? I've got an enable secret that is encrypted. It's hashed. What I want to do now is I don't need that clear text password. So I'm just simply going to go back to that enable password class, Control A, and put a no in front to undo that. Except there's no argument. You just use the keywords no enable password. And now if we go back and look at the running configuration, we still have our privileged exec level super user secured now. And if somebody's looking over my shoulder, they're not easily going to be able to see what the password is. So at this point, if I exit So I'm coming back in. I've got my exec level password set to secure the console, so I type in that. And this time, if I try to go to privileged access, privileged exec, and type in enable, or EN for short, I'm going to have to type in that password CLASS. So again, we're starting to secure this at different levels now. So always use enable secret rather than enable password. So the next step is to secure the in-band access, like if someone were to telnet or SSH in. These are VTY lines, which stand for virtual terminal. Those enable remote access. So you've got to configure your VTY lines as well if you're going to secure your device. And typically, Cisco devices are going to support up to 16 VTY lines by default that are numbered 0 to 15. So if we want to secure those VTY lines, that in-band access, privileged access, global configuration mode, and then the line command to go into line mode. And we're specifying which line, VTYs. And we can specify one or a range. So let's do them all at once to make it easy. So we'll say our range is 0 space 15. And that will apply the configuration the same to all 16 VTY lines. And we're going to apply that same password because this is the classroom, not the real world. So we're going to use the same password for simplicity, password space Cisco. And like the console, in order for that to be successful, we have to also accompany that with the login command. So password and login, remember, those are going to go hand in hand on those in-band and out-of-band connection configurations. And then end to go back to the privileged exec mode. So on Packet Tracer, on my switch here, I have applied the commands we've looked at so far. There's the console, and there are the VTY lines 0 through 15. So as you can see, those passwords are in clear text. Again, if somebody's looking over your shoulder, it'd be preferable if those were encrypted, just to help secure them a little better. So that's the next command we're going to look at. So to encrypt our passwords, the default being having them in plain text, we're going to have to use a command to encrypt them. And that command is service password-encryption. And that is a global configuration command. So if I go to Packet Tracer to my switch here, and I'm already in privileged exec mode, I'm going to go into configuration mode, and I'm going to type the command service. I'm just going to type in serv and use tab completion. And then let me see if tab completion works if I just type PASS. Yeah. Let's always try to do as little typing as possible, right? So tab completion, and then I hit return. And as soon as I do that, again, I'm going to use the do command to do a show run, which is a privileged exec command without having to exit to privileged exec. It's kind of a nice shortcut. Do show run to show the running configuration. So now there is an encrypted password for the console and the VTY lines. So not only does service password encryption encrypt those commands that were, those passwords that were previously put in for the lines and so forth, but it will encrypt any more going forward. And the purpose of this is strictly to prevent someone who's seeing this, who's not supposed to see it, from seeing the password. You know, this is a weak encryption compared to what you would see used on what's actually being transmitted across the network. The purpose is to keep unauthorized people from viewing these passwords in the configuration file. So the encryption applies only to the passwords in the config file, not to passwords as they are sent over the network. So another step in securing this new device is called a banner message, which is going to use the message of the day, banner message of the day, or MOTD command. By default, if we look at our screen, all it says is that the switch is available, press return to get started. So we want to warn unauthorized personnel from attempting to access this device. We're not wanting to welcome anyone who's not authorized. We want to create a banner message of the day. And what you do after you type the banner of the banner message of the day command in global configuration mode is you use a delimiting character, and then you fill in your message that you want to display, and then you terminate with another delimiting character. This delimiting character, where they're using the hash symbol in this case, that can actually be any character that you want it to be, as long as it doesn't occur in the message. And then once you enter this command, that banner is going to be displayed on all subsequent attempts to access the device. It stays in place. So for example, on the switch and packet tracer here, I've gone into global configuration mode and typed banner space MOTD for message of the day space, I'll use the hash symbol delimiter, and then I've typed in some asterisks and some text here. So again, at the beginning and at the end, I've got to have those delimiters. And when I go out of the switch now, that's a little less friendly and inviting. This next section will show you how to save your configurations. Now, if you're used to working on, like, say, a Linux system, for example, one departure you're going to find here is that if you're working on these network devices, if you reload that device or it power cycles and you haven't saved the configuration, that configuration change that you made is going to get lost. Whereas if you're making a change on a Linux server and you restart that server, it will have stored that configuration. It would have been kind of saved as you go. So this part is important to avoid losing any work. So basically there are two parts of the device that's storing the device configuration. So for example, when I changed that banner just now and it applied the change when I went back out and came back into the switch, so it looked like it was saved, right? Well, it is saved for as long as the device is running, because it's saved in a volatile part of memory that gets erased when the system reboots. So this is called running config, and that's going to be stored in your random access memory. As I said, that's volatile. That reflects the current configuration, all of the changes you've made in this session since it's been rebooted the last time. So that's going to affect the operation immediately as far as the RAM is concerned. You're going to want to commit those changes, so to speak, if you want them to be permanent. So at this point, they're not permanent. If you got yourself in a real bind and something you did really screwed something up and you're not sure what it was and you're completely desperate, well, if you reload that device, that'll undo everything you did, but then you've lost everything you did. But what you want to do is look at your non-volatile RAM, because that is where something called the startup-config is stored. Non-volatile random access memory, and that is going to contain all the commands that are going to be invoked upon startup or reboot, and that's the flash. That's called the flash memory. That's not going to lose its contents when the device is powered off. What you can do is to save the changes that are made to the running config so that they apply to the startup config file that's read at startup, hence the name. You use the command copy, and then running-config is your copy from, and then you're copying to startup-config, and this is a privileged exec mode command, or a super user command, if you will. When you want to see the contents of your startup configuration, you would do the show startup-config. So in my switch here, if I just type show star, it's saying that's not present. That is because this is the first time that this switch has ever been up. This is straight out of the box. So if I do a show running config, or I can say just simply show run for short, or hit tab for tab completion, that's going to show me everything that has been configured. So if I were to reload this switch right now, I would lose everything that I've just done, because startup config is empty. So what I want to do is say copy, and for short I can say run, copy run to star, but I'll tab completion just so you can see it. Show running config, I'll say just star, and then tab completion shows that startup config. Destination file name, just hit enter to accept the default. So now when I say show startup config, or show star for short, now I've got all of my config changes that I've made are now saved and will be applied if I reload the switch. Another thing that you could do is you can clear that by saying erase startup-config, and then you could reload if you need to apply that. So now if I were to say erase star, and it's going to warn me, I'll say yes, I'm sure. So now it has erased non-volatile RAM, it's initialized it, and now if I go back and do a show star, it's back to the way it was, not present. So again, if I do decide that everything, I do want to keep all this, I can later decide, as long as I haven't reloaded, I can go ahead and copy run to star, copy running -config to startup config. If you want to capture the current configuration so that you can make changes or just have a record, one way to do it, if we're in the classroom, we're not going to be using a terminal emulation software app because we're using Packet Tracer. But one way, if we're using Packet Tracer, we can say show config to see the, or show run to see the running config. You could actually just simply copy that and paste it into a text document such as WordPad, so then you could have a record of it in a text file. And the nice thing though, if you're working in a company as a network administrator using a terminal emulator, commonly PuTTY, and one really nice feature of that is something called logging, where you can, in your terminal emulation software, you can enable logging. And once it will log everything you do once you log into that device, which is also important. Like when people do network configuration changes in production, it's a great way to capture all their steps. And this is really nice to have a record of actions done, or you could use that text file you created not just as a record of what was done, but if you wanted to make a new device that's exactly like the old device, you could take that file, change the parameters that you want to change to use as input, and then you could paste it into the new device without having to repeat a lot of the work. Once you have your basic configuration down, you want your devices to be able to communicate with each other, right? Across the network. So to do that, each of them has to have a unique, appropriate IP address and be correctly connected using the right network media. Now we're going to learn how to do that. IP stands for Internet Protocol. An Internet Protocol address is a unique address that will assign a reachable location to every device that's on your network, whether that be a smart doorbell or a PC or a smartphone or a security camera or a voice over IP phone or a network printer. Every device has got to have an IP address in order to be network reachable. That might be an IP version 4 address, and then we've also got IP6 addresses, which are 128-bit values, as opposed to the IP4 32-bit value. And because IP version 4 addresses have been all consumed, IP version 6 allows enough addresses for everybody. What we will look at right now is the IP4 address. This is called dotted decimal notation, and it's represented by 4 decimal numbers between 0 and 255. And then each address will have a subnet mask that goes with it. Both the address and the subnet mask are 32 bits. The difference is that one is the specific address, and the subnet mask is what tells the network how many of the bits in the IP address are network bits and how many are host bits. So this subnet mask is 255.255.255.0, and that tells the network that these 3 octets are the network portion, and then the 0 here indicates this is not a network portion of the address. This is the host portion. So that means the network number here is 192.168.1.0, and it's host number 10 on network 192.168.1.0. So the mask is just as important, and it has to be hand in hand with the IP address. And then the default gateway is important because that is the IP address of the router or gateway to the rest of the world that host will use to reach remote networks that are not part of the local network, such as to reach the internet. This PC or whatever device it is that's host number 10, if it needs to reach the internet, it doesn't know how to get there. So it's going to contact its default gateway, which has the address 192.168.1.1, and that default gateway is going to do the rest of the work. So that is always going to be on the same network as the host. So they both have the same network number, 192.168.1.0. It's just that the default gateway is host number 1 on that network, and this client here, or end device, is host number 10. As compared to the decimal values in IP4 addresses, IP6 addressing uses hexadecimal values and are 128 bits in length. And each of these hexadecimal values represents 4 bits. For example, this 2 represents 4 bits, this 0, and so on and so forth. And in hexadecimal, 10 equals the letter A, B is 11, C is 12, D is 13, E is 14, and F is 15. This uses colons instead of dotted decimals to separate groups of every 4 hexadecimal digits. These are not case sensitive. You could write this as uppercase DB8, uppercase ACAD, and it would be equivalent. As I mentioned, IP6 is gradually replacing IP4 because IP4 addressing is consumed. So you will see these 2 versions of IP coexisting, and you may have both versions running in your home. As far as network media goes, we covered that quite a bit in Module 1, but mainly each physical interface has standards or specifications that define it, and you just have to make sure that the cable connecting to the interface is designed to match the physical standards of the interface. It just depends on which media you choose is going to depend on the distance you need the signal to be carried, the environment, how much bandwidth you need, and also the cost of the installation. For example, like if you look at copper type of network media, that's going to be found again, most common on local area networks on LANs. Ethernet ports are also going to be found like on your end user devices, like your PC, are used to physically connect to the network using a cable. If you're running a layer 2 switch in Cisco IOS, which is where your users normally connect to, those ports are typically not going to support layer 3 IP addresses. Remember a little bit earlier when I was trying to assign an IP address to a switch port and it wouldn't let me, it gave me that error. That's because that was a layer 2 switch, and those ports are not really intended to have IP addresses. In this case, it was a 2960 model switch. On a router, you would have IP addresses because routers need to do routing. So they're using IP addresses, and they're going to have route tables of all the different routes and networks. You are going to see IP addresses on all the router interfaces, but on a switch you might just have a single IP address that's just used for management of that switch. In this case, if I go back and look, just hover the mouse over it. So I have an IP address down at the very bottom of the IP address list, which was for the management interface. But all the user ports are not going to have IP addresses because those are layer 2 ports that we'll learn about later. But the end users themselves, like the PCs that connect to that switch, those will have IP addresses on them. Because the IP address is analogous on a device to where you live, your unique address. You've got a house number, a street name, and a zip code that's unique to you, so that postal mail or package or something, so that can get delivered to you specifically, and it's the same with networking. Every device has to have that kind of unique address so that the packets that are destined for them be received by them. It's just that those can be either IP4 or IP6 addresses. So how do you configure an IP address? Let's start with an end device. You've got to have an IP address on your end device, such as your PC or your phone. And a lot of times that's all done without you even knowing about it through something called Dynamic Host Configuration Protocol, or DHCP, where that information is all done automatically by a designated server, a DHCP server that has an address pool to take from, and it can parse out those addresses to the devices on the local network. So for example, on a Windows device, under Control Panel, Network Sharing Center, Change Adapter Settings, if this radio button was selected to obtain an IP address automatically, that would bring the DHCP into play. If you need to address a device manually, you would choose the radio button, use the following IP address, and then you would fill in the IP address you've been given, and with the correct subnet mask, which is going to designate 192, 168, and 1 as network portion, and in this case 10 is the host and 1 is the default gateway. And if you need a DNS server, you could put that in manually, or you could also choose to get that assigned manually. Now, as mentioned, a network switch, which is the layer 2 device that, say, the end devices connect to, the individual ports don't need to have an IP address because the end users that connect to it have IP addresses. That switch does have to have an IP address and a subnet mask to be managed or connected to be configured or, monitored or anything like that. There's something on that switch which is called an SVI, which is a switch virtual interface. This SVI is a virtual interface that you can put an IP address on so that it's reachable. So this is going to be by default called interface VLAN 1 on the switch. And to access that, you go into privileged exec mode and then into global configuration mode. And then you're going to assign it an IP address and to enable it so that that switch can be connected to over the network from the outside world. And to do that, you would go into global configuration mode, and then you would specify the interface command to go into interface configuration mode. And then the name of the interface, the SVI, switch virtual interface, is VLANs 1. And that'll put you into interface configuration mode. And from there, the command to administer assign an IP address is IP address. And then, again, we're using network 192.168.1 in this example. And this is going to be host number 20, because this is the host portion. And that is, again, unique to this device. And then this is the network mask, which is showing that the first 3 octets or portions of that dotted decimal address are the network portion. And then the 0 indicates that that 4th octet, or 8-bit portion, is the host address. And in order to enable any kind of interface, whether it's a switched virtual interface or a physical interface, is no shutdown or no shut for short. And once you do that, that interface will be reachable. So on my switch here in the packet tracer, I did that same thing. I said interface VLAN 1, or in this case it does not have the space, and then IP address. In this case, my address is in the 10.0.0 network because the mask is showing us that these 3 8-bit sections or octets are the network part, and this is host number 2. And then if I go back out, I've got an upstream router that's connected to that, and so I can actually test the connectivity of that switch by pinging that address I just showed you was assigned, because this router is the default gateway. I've got a success rate of 100%. That address does work. I could actually, because we configured the VTY lines to allow remote access and we set the password of Cisco, so I can actually telnet to that address, and I'm now connected to the switch over the network. And if I say show IP interface brief, I can see there it is, VLAN 1. That is my switched virtual interface. One way that you can verify connectivity is to use the ping command that I just used in the previous example. By this point, hopefully you're ready to test your knowledge on the module quiz, and that brings us to the end of Module 2. We covered a lot of really important foundational material that I hope will help in future modules.